Alright, so this is my lesson video on the review of section 9.1 through 9.3. I have lesson videos on each of those separately, but this is one where we just kind of go back and recap so that you can get ready for the 9.4. So what you will want during this lesson video is, of course, your color-coded periodic table. So hydrogen, we have not talked about how to name acids yet, so that's its own category. Regular metals include group 1 and group 2, not hydrogen and aluminum. Our transition metals include the transition metals, the metals under the stair-step that aren't aluminum, the lanthanides and actinides, they can have multiple charges. And our nonmetals include everything to the right of the stair-step, and although hydrogen, of course, is a nonmetal, when something starts with hydrogen like an acid, it has its own rules for naming. Alright, so we're going to go ahead and review sections 9.1 through 9.3. So we're going to cover how to name regular metal compounds, transition metal compounds, and compounds that start with nonmetals. Alright, so the regular metals include group 1 except hydrogen, group 2, and aluminum. When naming a compound that starts with a regular metal, you name the first element and add "-ide" to the second element unless it's a polyatomic ion. So you might also want to get your polyatomic ion sheet out too. When writing the formula, don't forget to balance or cross your charges. So it says, write the name or formula for the following. So we have AlBr3. So I can go to my periodic table that I color-coded and see that Al is a regular metal. So I don't need a Roman numeral, I don't need prefixes. All right, so we just name the first element. So Al is aluminum. And we add "-ide" to the second element. So bromine becomes bromide. Remember, in the naming, I don't need to in any way address the subscripts. Alright, so sodium sulfate, I need to write the formula, so I need to remember to cross or balance my charges. So sodium is Na. It is in group 1, so make sure you have labeled your charges across your periodic table. +1, +2, skip the transition metals. +3, positive or -4, -3, -2, -1, and 0. So sodium is in group 1, so it has a +1 charge. Sulfate is on your polyatomic ion sheet, so it's SO4 with a -2 charge. Now remember, this whole thing has a -2 charge, so don't focus on that 4. So since I have +1 and -2, I need to cross my 2 down. So I end up with Na2SO4, and remember, you are more than welcome to leave the charges in your answer if you want to, but they are not required. When I check a formula, I'm only, of course, checking for your subscripts. All right, so let's move on. So there's our answers. So I want you to try a couple, okay? This is review, so you should be able to tackle these. All right, so just pause the video, try for a minute, and then check your answers. All right, so LiNO3. Li is in group 1, so it's a regular metal, so I know I don't need any Roman numerals, I don't need any prefixes. So I just name the first element, so Li is lithium, and then I add "-ide" to the second element. Well, in this case, I have a polyatomic ion, so I don't even need to change the ending. I look at my polyatomic ion sheet, NO3 is nitrate. So I just write nitrate, lithium nitrate. That's it. So hopefully you got that one right. All right, next one is SrCl2. So I can see that Sr, strontium, is in group 2, so that makes it a regular metal. So I just name the first element, so Sr is strontium, and I add "-ide" to the second element, so chlorine becomes chloride. Again, I don't have to focus on that subscript at all. Alright, so here I've given you 2 names of regular metal compounds, so I need to remember to cross or balance my charges. So barium oxide. Barium is Ba, it's in group 2, so it has a +2 charge. Oxide is O, oxygen. It is in group 16, so it has a -2 charge. Now remember, some of you get real fast at crossing charges. A +2 and a -2 already cancel, so I don't need to cross. So my answer is just BaO. Remember, you can leave the charges, you don't have to have the charges. Either one is fine. Alright, so last one, hopefully you've been getting these right, is magnesium phosphate. So magnesium is Mg. I can see it's in group 2 on the periodic table, so that means it has a +2 charge. Phosphate is on your polyatomic ion sheet. It's PO4 with a -3 charge. Alright, and so this whole thing has a -3 charge. So positive 2 and negative 3 do not cancel, so I cross my 3 down. And how do you cross something down to a polyatomic ion? You put it in parentheses. Now because I circled it, I know this whole thing has turned into a big mess, but your formula should look like this. Mg3 parentheses PO4 parentheses 2. All right, remember, you can keep your charges at the top if you prefer, but you don't need to because it's bonded at this point. All right, so hopefully that was a little reminder of how we name and write formulas for compounds that start with a regular metal. And so here are our answers. So now let's move on to section 2 review. So the transition metals include everybody in groups 3 through 12, the little triangle of other metals that go up under the stair-step, and it includes your lanthanides and actinides. Remember, I will call that whole group the transition metals, though, just to save time, because it just includes anything that can have more than one charge. So when naming compounds that start with a transition metal, you name the first element, add a Roman numeral to indicate the charge, and add I to the second element unless it's a polyatomic ion. So in other words, it's the exact same rules as for naming with a regular metal, except we just need a Roman numeral. When you write the formula, still got to remember to balance charges. So, old names is of course just for honors, so we don't need to focus on that. So let's look at these two together. So I need to write the name for Fe2O3. Well, I know Fe is iron. I know it is a transition metal, so I'm going to need my Roman numeral. And I know oxygen becomes oxide. So now I just got to figure out what is the charge on iron, because we can't tell by looking at it because it's in the transition metal location. Well, we know oxygen's -2, but since there's 3 of them, that's really -6. So what cancels out -6? +6. But I have a subscript, so remember, it's like me dishing out money. If I have $6 to split between 2 students, they each get $3. If I have 6 positives to split between 2 atoms, they each have a +3 charge. Once I determine it is a +3 charge, I know it is iron 3 oxide. All right, so for this one, I gave the old naming system for honors, so just disregard this and pretend like it says copper 2 sulfite. Okay, probably should have changed that. Oh well. All right, so copper 2 sulfite. So we need to write our formula. So we got to remember to cross or balance our charges. So copper is Cu. The Roman numeral tells me the charge, not the subscript. So it's a +2 charge. Sulfite is on your polyatomic ion sheet. It says SO3 -2. And so then don't be real quick on crossing those charges because +2 and -2 cancel. So I don't need any additional subscripts. So it's just CuSO3. All right, so hopefully that's jogging your memory of us doing transition metal naming and formula writing. So let me let you practice some on your own. This tends to be, well, this and acids, which we haven't gotten to yet, tend to be the ones that people struggle with the most. All right, so you try these two. Don't worry about this old name. That's just for honors. So just name it like we normally would with our Roman numeral. All right, so I'm going to assume you've paused and tried these, so let's look at them together. So zinc 2 permanganate. So I know zinc is Zn. And that Roman numeral 2 tells me it is a +2 charge. Permanganate is on your polyatomic ion sheet. It's NnO4 -1 charge. So I need to cross my charges. I don't need to cross an understood 1, but I do need to cross the 2. How do we cross a number to a polyatomic ion? We put it in parentheses. So again, if you want to see what it looks like without the charges, and remember, you are more than welcome to leave the charges, though, if you want to show your work. All right, so our bottom one, we need to name this. I know I need a Roman numeral because Cu is a transition metal. Anything that starts with anything in that transition metal area needs a Roman numeral. So I know Cu is copper. I know it's a transition metal, so I'm going to need a Roman numeral, and I know oxygen becomes oxide. So now I got to figure out what the charge is for copper. Well, I know oxygen's -2. That means I need +2, but we have that splitting situation. +2 divided by 2 means they're each going to be +1. Once I know that, I know it's copper 1 oxide. And I know that's tricky because you see Cu2O and you want to call it copper 2 oxide. But remember, the Roman numeral is the charge, not the subscript. The Roman numerals just take some practice. You just got to practice. That's all you can do. All right, and don't worry about this. That's just the old name. Oh gosh. All right, so now let's move on to our Section 3 review. So a lot of you, Section 3 is your favorite because you get to use the prefixes. So the nonmetals are located to the right of the stair-step line on the periodic table, and even though hydrogen is a nonmetal, when we're naming and something starts with hydrogen, we're going to follow the acid rules. When naming compounds that start with nonmetals, use prefixes to indicate the number of atoms, except when the first element has one atom. So the first element will never start with mono. It can have other prefixes, but it won't have mono. The second element always has a prefix. And then don't forget to add ides to the second element. When writing the formula, you do not balance charges. Most nonmetals are negative anyway, but they're not even charged particles. They are sharing electrons. So you use prefixes to tell you what the subscripts are going to be. So it says write the name or formula for the following. So we have N2O. So I know nitrogen is a nonmetal, so since it starts with a nonmetal, I'm going to use prefixes. So what would two nitrogens be? It would be dinitrogen. And what would one oxygen be? It would be monoxide. Because one means mono, and then don't forget to add that IDE at the end. So dinitrogen, monoxide. It is okay to use mono for the second element, but the first element only has a prefix if you see a subscript. Now notice I dropped one of the O's on mono. I didn't put monoxide. If you did though, I would mark that right because you're showing me you're following the rules. All right, so next one we have diphosphorus pentoxide. Well, phosphorus is P, di means 2, oxide is O, penta means 5. So it's P2O5. Notice I did nothing with charges. You don't have to do charges because these are molecules. They're sharing electrons. They're not charged particles at that point. All right, so let's see if you can do some on your own. All right, so pause real quick and try these and then check your answer. All right, so we have CO, so I know C is a nonmetal, so I'm going to need prefixes. My first element only has one, so I'm not going to use a prefix. I'm just going to write carbon. My second element only has one, and so I will use a prefix. So my prefix for one is mono, and oxygen becomes oxide. So it's carbon monoxide. Don't forget that ide ending. All right, my second one, my first element only has one, so again, I'm not going to use a prefix. C is carbon. My second element has 4. 4 is tetra. And so chlorine becomes chloride, so it's carbon tetrachloride. Don't forget to do that ide ending. All right, so our next one is nitrogen trihydride. Well, nitrogen's N. Hydride is just hydrogen with an ide ending. So oxygen becomes oxide, nitrogen becomes nitride, hydrogen becomes hydride. So it's hydrogen, and tri means 3. All right, phosphorus trichloride. So phosphorus is P, chloride is Cl, and tri means 3. And so again, notice that I did nothing with my charges because these are not ionic compounds. These are molecular compounds. So they are just sharing electrons. So hopefully that was a good review for you of sections 1 through 3 for chapter 9. If you need more review, go back and find the actual section 9.1, 9.2, and 9.3 lesson videos, and I go into much more depth, but this is just kind of a brief review. So get ready because section 9.4 is next.